So I want to go back and do the truncated. If I'm not sure if I'm going to use this, maybe this is a what-if scenario. I'm not sure I'm going to use the combine and the mirror. I can always suppress those, and the suppression state will return this to a previous condition. And because I've rotated this over, I've got some interesting things going on that when we look at the truncated geometry on the right square, it's kind of going across one of those faces. So since I've made that adjustment, let's just do some experimenting on which way these planes would go. So if I go to the front plane and open a sketch, and I just pick an angle, and I'm just going to do the extrude cut. And because these edges are able to project into the current plane, they're gonna be valid to create our geometry, even though they're kind of moving away from the current plane. All right, so if we rotate over, you can kind of see that this is at an angle projecting forward, but it creates a line through the sketch, projected into the sketch to make that work. All right, so if I go in and do the extrude cut, I want to pay attention to the arrow, the direction, and we can tell it to go through all both. And that makes kind of a really weird compound angle. So that wasn't really the desired result we're looking for. So again, I'll just go in and suppress that. I'm not sure if that's going to be usable at some point. And I don't really just want to haphazardly delete some of these geometries in case I need to come back to it and make it work. So if I go into a sketch on the face, I need to make sure that I'm going through all of the geometry, and that's kind of a weird angle. So if I go in and I do the 1 inch for the truncated face, this is going to extrude in the direction of the cut. Now, because I'm also on that angle, it means that in relation to the say if I was to drop that line straight down, create a plane through that cut, I'm not generating the exact same geometry that I would if I was on the front plane again. And then to be aware of is to extrude cut. This is going to go perpendicular or to that face. So if I tell it to go through all, cutting directions the right side, could not. Let's try through all both. Oh, it probably based on the preview. Looks like the angle is such that it's gonna chop and it's not going to be able to extend all the way through, where when we were going in that direction, at least the compound was part of it. So that being the case, let me go back Control 8, and we'll hit the X out of the cut extrude, L on the keyboard, and I'm just going to extend this out to where I can see those projected up against the other edges. All right, and because of the inferences, it got collinear, it got coincident, got collinear, it got coincident. And let's see if that's going to solve the issue with it cutting all the way through. All right, so that made an even more stranger faceted shape. So one of the things we'd want to look at there is making it so that it will cut straight across. All right, so it's cutting through the loft, and we can go back to the direction of the cut, and if I give it a edge for it to follow, it will make a cut that looks more like we wanted, except for, well, let's see what that point is, and I would probably need the plane, and then we can measure. And so my 1 inch distance along the angle, because of our trig, works out to 0.89. All right, so there's probably a better way to do that, and that gets us started with with our geometry. All right, so again, these are for fun and to kind of just go through techniques and visualize shapes, and just to keep continuing to introduce the tools and the geometry. So we did the tetrahedron. A right triangle would just be stretching out that plane or that axis to get us a little bit more height. the right square we just did, the oblique pentagonal. Now let's see what we can do with that. All right, so same type of geometry. Take another quick look there. So this one's going to a face. It would be pretty much like the prisms. Well, let's go ahead and see what we get. So again, more experiments. We'll go into the polygon, make sure we have a 5-sided shape. Can't really tell which way the vertex was pointing, so let's just make one of those horizontal and we'll give it a size. Kind of looks like it was going towards one of the points, so we'll just make it go that way. All right, so my base circle will give a dimension to 2 inches. And since I have that geometry, we'll go into the front plane. We need an angle for it to follow to become an oblique. And we'll give it some distance. 3 inches should work, and an angle. Well, I don't really have anything to pick there for the angle, so just a quick center line to be able to apply the smart dimension. 60 degrees should work. So when I pick the center line and the object line, since they're not parallel, it's going to ask me for, or it's going to result in an angular dimension. And actually, should have brought that the other way. So if I go to 120 and rebuild, so that'll put it in the direction of the angle. So let's go ahead and take sketch 15 and extrude it. And then we will go up to, well, let's get the angle in there. And then if we were to put a draft on that and bring it to a point, not exactly my favorite method because it's going to be harder to control getting that facet to the point and creating the shape. So let's see what it results in, if that's going to work. So it doesn't quite come to the same point and to the angle. So that one's going to have to be analyzed a little bit more. Okay, so let's go ahead and hide that solid. That was a non-starter. What about our right triangles, right pentagonals, right hexagonals? Okay, so the oblique hexagonal, pretty much in the shapes that we've been doing. So let's go ahead and start those. And I'm starting to get quite the list. And at some point, I want to consider doing a folder or some type of geometry to, or some kind of method to organize the geometry. So if I go with the octagonal, and we'll pick one of those, make it vertical, put a inscribed circle of 3 inches, and it didn't accept, so we'll just go ahead and extrude it. And again, with the direction, I'll use sketch 16 again, maybe. Okay, so that's kind of going away. It might be too critical for it. Entire sketch cannot in the same direction. All right, so maybe it is too long. So if I were to give that an up to vertex, I'll go ahead and see if I can show. All right, so if I right-click on it and I show the show the sketch, I can go up to vertex, which is the endpoint of the line, and then the direction. And now we have a situation where it can complete. Okay. So we'll hide that one and go ahead and hide the sketch to kind of clean up. The other two should be relatively easy at this point then. So the top plane, we'll go back in, set our 3 sides. And then the main thing that will happen if we don't fully define, maybe I'll put the dimension on this, and I'll leave this one fully defined, or underdefined, and extrude it out, and 4 inches is fine. Right, so what can happen is that we've turned off Instant 3D, but because this is underdefined, no, we want to keep that dimension. Let's see which one of these is going to allow me to rotate. So if I'm not fully defined and I don't have the geometry nailed down, it's not, well, I guess I got it a little better defined than I expected. Instant 3D though allows this to move, and one of the reasons I wanted you to turn it off is you accidentally click on this, you're changing that dimension, you're changing that geometry. If I get a full orbital, I'm going to be able to move this and its relations. There we go. And the size and the rotation. All right, there I got it going. So it can Instant 3D can produce some strange results that you might not be happy with. All right, and then what was our last one? The right pentagonal, which we tried with the oblique. And it'll be basically the same strategy of shape, polygon, draw, and even after the fact I can switch it over to 5. I'm going to pick one of those vertices to make horizontal or vertical to the origin, and then place a dimension either linear or on the base circle so that we can create that geometry, and then extrude the geometry out. All right, so that will give us our shapes. And what else do we have? So we've done most of those. I think we can probably get the ellipses in there, our little egg shapes, and we have a couple of options on those. So let's go ahead and hide our solid body again. Let's go front plane. I'm going to go ahead with a center line. This time I'll do horizontal infinite length, place it on the origin. And when we do an ellipse, you're going to have an ellipse, partial ellipse, and then under that is the parabolic and the conic, which are derivatives of the cone, and depending on how the cone is cut. With an ellipse, we're going to drag major or minor axis. It's not really determined until we complete the cut, or complete the drag on the geometry. And then we're going to end up with these grips, these handles that are actually going to define the major and minor axis of the geometry. So if we do, say, that and that, 7 inches, and I want to revolve this, but the problem with the revolve is this is going to generate self-intersecting geometry. So if I go to revolve, oh, missed, we'll just exit out of the boss base, revolve boss base, and then this becomes an area where I want to use the selected contour, so when it goes 360 degrees, it won't self-intersect. All right, so that gives me the horizontal. My other option then is on the front plane, we'll do the vertical slightly different. Center line, vertical, infinite length. And I'll accept that. And my other option then is to do a partial ellipse that requires 2 drags. So we get it close, we get it into position, and then I drag from point to point to create the shape. It still gives me those node points for the ellipse, and I could define it as if it's one complete geometry. But now I've just got the partial. I'm going to do a little bit different there. And because this is with the revolve is not a closed section, it would ask me to close it. If I don't see that shaded sketch contour, it would ask me if I wanted to close it. So go ahead and do that. And then the revolve base, because there's a center line, automatically goes ahead and does it. So if I show those, now we have the intersection. And back to the other options on the combine, I don't get to use those very much in the types of things that I do. So if I wanted one of these to be subtracted, we can use that as the main body and subtract that body and have a result. Basically the ellipse being removed from the center. Or if I go with the common geometry, and we see that that is the result of the intersection of the two ellipses. So some interesting geometries that we can create. I will see if I can come up with something on the oblique pentagonal that it may end up that has to be a surface, and we'll revisit it with a dodecahedron and a icosahedron because those the best solutions that I've found have an included surface. So something to look forward to.